Yeah, good evening, dear students. Today I am going to explain application of integrals in trigonometric functions. In the previous, I have done three videos. One is application of integrals with the modulus functions. Second one, I have done application of integrals with parabola, and another one I have done application of integrals parabola with line. Now application of integrals especially with trigonometric functions. These are most important. I am going to cover 9 questions. You can expect at least one question from this 9 questions. The next session I will do like combination of ellipse, triangle, or ellipse, circle, triangle related problems. I will complete the next session. Now, I will continue the problems one after one you see here. This is the most important problems in trigonometric functions. This is the first problem now. So these are the problems, application of integrals, trigonometric functions. So total 9 problems. It covers all the models of the class 12th, chapter number 8. No doubt in that. See the first problem now. Find the area bounded by the curve y equal to cos x between x equal to 0 and x equal to 3 pi by 2. They given x equal to 0 and x equal to 3 pi by 2. That I am going to explain the first problem now. See the first problem now. Find the area bounded by the curve y equal to cos x between x equal to 0 and x equal to 3 pi by 2. So this is the first problem I have taken here. See now when I have taken the first problem, area, the saying here cos x, they are asking y equal to cos x. First we will draw the graph of y equal to between 0, 3 pi by 2. We will draw the graph of this one. Then you will understand this. I can consider this is the origin I have taken. I am drawing the graph. The points I can consider between pi by 2 here, 0 to pi by 2, pi by 2 to, I can write this is pi and 3 pi by 2. I have taken the points here. The cos x maximum value will be 1 only, right? Maximum value will be 1 I can consider. Maximum cos x. If we take 0, between 0 to 3 pi by 2 they are asking. So you can see when 0 here, what is cos 0? If we take cos 0 is 1. Correct? I can draw the graph here. Cos 0 is 1. We know that when cos 0, when x equal to 0, you will get y is equal to 1. When x equal to 0, cos 0 is 1. When x is equal to pi by 2, cos pi by 2 will be 0, right? So when x equal to pi by 2, just I am giving when x equal to pi by 2, y equal to 0. When x equal to pi, just I am giving an idea about these values here to draw the graph of this. So you take x is equal to 0 means y is equal to 1. X is equal to pi by 2. You will get y is equal to cos pi by 2 0. X is equal to pi. Y is equal to cos pi by cos 180 minus 1. When x is equal to 3 pi by 2, it will be y equal to 0. Look into this, you get an idea about the graph of this. Now I can draw the graph of this one. At 0 it is 1, pi by at 0. It will come like this. It will go like this. This is the graph of this. 3 pi, this is 3 pi, but this is pi. Because I can consider this is minus 1 here. If I extend that line, is a minus 1 here. Because this is y x dash, correct? Just like this is 3 pi by 2. They are asking this is the required area. Is it clear? That is the required area they are asking, right? Now you see when I am finding the required area, graph of drawing the graph 0 to 3 pi by 2 they are asking. But without solving the problem we can tell the area. This is one loop. This is 2, this is 1, 2 plus 1, total answer 3 square units. This is half of the loop, 1 square unit. This is 2 square units. The answer is 3 square units. But this is not objective question. We should solve that between 0. This is the required area. I can shade that What is the required? I can share. This is the required area. Now when I'm doing this, I can write now the required area is equal. I can write required area equal to this between 0 to pi by 2. Between 0 to pi by 2, curve is above x-axis, cos x dx. I can write pi by 2 to 3 pi by 2. Pi by 2 to 3 pi by 2. So here x-axis y equal to 0. Curve cos x is below x-axis, upper curve minus lower curve. When I have taken upper curve minus lower curve, this is upper curve is like x-axis y equal to 0 minus cos x, you will get minus cos x. I will repeat the reason, upper curve minus lower curve. Here curve is upper curve, here minus lower curve is y equal to 0. Here y equal to 0 minus y equal to cos x. So you will get minus cos x. Now if I simplify this, integral cos x. What is integral cos x is minus, integral cos x is sin x. You can write sin x, you write this sin x, limits 0 to pi by 2, minus again integral cos x sin x, limits I can write this is sin x, be careful, sin x, limits pi by 2, 3 pi by 2. Pi by 3, but if you substitute this, sin pi by 2, 1 minus sin 0, minus sin 3 pi by 2 minus 1, sin pi by 2, 1. It comes 1 plus 2, which is 3 square units. Answer is 3 square units. That will be your answer, 3 square units. This is a basic problem, you should learn this. That is why I explained this. They may ask this question for like 2 marks or 3 marks they may ask. This question is important one. That's a basic one. Now see the next one now. This question. Find the area bounded by the curve y equal to sin x between 0 and x is equal to 2 pi. Between x equal to 0 and x equal to 2 pi. There is what area bounded by the curve y equal to sin x between x equal to 0 and x equal to 2 pi. Here also, first you draw the curve between 0 and 2 pi. Try to draw the curve here. You take this one. I can write. They are talking at 0. At sin 0, 0. You can think about the some values you can think. Easy to write that. So I can write. This is I can write pi by 2. Pi. And 3 pi by 2. And 2 pi. 3 pi by 2. 2 pi. But just you take 2 pi. Maximum value of sin x is 1. I can write 1. Substitute sin 0, 0. It will, the point will come here. Sin 0, 0. Sin 90. Sin 0, 0. The point will come here. Because you can think this is the point it will come. Sin 0. The graph will come. Sin 90, 1 it comes. Sin 180 is 0. Sin 3 pi by 2 it will be come minus 1. The graph will come down. You can think the graph will come down. See the graph will come like sin, this graph goes like this, sin the curve. Like this, correct? It will come like this. So this is a rough sketch only. This is a rough sketch. This is the pi, right? This is 3 pi by 2. Correct? Do you think of this is 3 pi by 2? Whatever, this is 3 pi by 2. 3 pi, the graph will come minus 1, right? The graph will come like this. This is pi, this is 2 pi. Correct? This is the pi here. Pi by 2, this one, maximum 1. So now the required area is, you can see, this is the required area. They are asking this is the required area. Because without solving the problem, we can deliver answer here. 4, this is 1 loop, this is 1 loop, 2 plus 2, 4 square units. Answer is 4 square units. Answer is 4 square units. Now, you have to draw the graph between 0 to pi upper curve. This is lower curve here. I can write required area equal to, required area equal to, between 0 to pi. Up curve is upper, sin x dx. pi to 3 pi, pi to 2 pi, pi to 2 pi. You can consider. I can consider pi to 2. Otherwise, I can also say this is symmetric with this. Simple, I can 2 into 0, 2 pi I can write. Same thing I can write. Instead of that, doing this, because this one actually, what about this area is reflected to this area. Both are same here. Instead of writing here 0 to 2 pi, 0 to pi, pi to 2 pi. This length is same. So I can write 2 into 0 to pi sin x dx we can write. Because this area is equal to this area I can write. 2 into 0 to pi sin x dx we can write. Even if you understood here 0 to pi, whatever the area will be, same way it comes pi to 2 pi. And then I can write 2 into 0 to pi sin x dx also you can write same area. Otherwise, you do it 0 to pi, pi to 3, pi to 2 pi also same result it comes. No doubt in that. You can do that way also. Both the ways I can tell you because this area is same. The length will be same. 0 to pi, pi to 2 pi. If we take this one 2 into integral sin x minus cos x 0 to pi. Minus 2 into cos 180 upper limit. Cos 180 minus cos 0. It comes minus cos 180 minus 1 cos 0 is 1. It comes answer 4 square units. Answer 4 square units. This is our answer. The people anyhow confusion means I can tell you another way also. Same problem, you can do 2 ways. I told you this one. You can also do, here you can remember, or you can also write this required area. Required area. This was you can write 0 to pi. You will get sin x dx pi to 2 pi, pi to 2 pi minus sin x dx. You can also continue like this. 0 to pi sin x dx, below x axis minus sin x dx. You can do like this also. It gives same result. You simplify, it gives 4 square units only. You do that. Or this also you can do 0 to pi, pi to 2 pi. No issue, you get the same answer. This was you can solve that. Because both areas are equal, written twice of this. If you don't want the first one, follow the second one. This is required area. It gives same result. Required area equal to, like this I can write. 0 to pi sin x dx plus 0 to pi to 2 pi minus sin x. You simplify that, it gives 4 square units only. Both the ways you can do that. Because the reason you should tell why 2 into 0 to pi. This area equal to this area. Pi to 2 pi. Because the length is same. 0 to pi, pi to 2 pi. So that is the reason I have taken like this. Or you can do like this. Next. Another one. Y is equal, find the area bounded by the curve. Y is equal to 2 sin x plus sin 2x for 0 less than or equal to x less than or equal to 2 pi and x axis. See in this problem, you observe this problem. In the third problem, if you observe the third problem, see here, you will get in the third problem, right. Just look at the third problem, what I am going to explain. Just observe this. Find the area bounded by the y equal to 2 sin x plus sin 2x for 0 less than x less than or equal to 2 pi and x axis. And x axis. So here, the maximum value you can see here. This is the curve they are given 2 sin x plus sin plus 0 to 2 pi they are saying here. 0 to 2 pi. So this curve, we can verify where it intersects x axis, we will verify. For example, you take y is equal to 0. If you take y equal to 0, it comes, when I have taken y equal to 0, then I can write 2 sin x plus sin 2x means 2 sin x cos x equal to 0. You take 2 sin x common, 1 plus cos x equal to 0. Then you will get sin x equal to 0. Just observe here. Sin x equal to 0. Sin r, you will get cos x equal to minus 1. Sin x equal to x is equal to pi by 2. Cos x equal to minus 1 means it will come 0. See the value here. Cos x equal to sin x equal to pi by 2 means in between 0 to 2 pi. I can write sine value 0 means 0 I can consider, even 2 pi I can consider. When cos x equal to -1, x is equal to pi. We have 0, 2 pi, pi. These are the values we got. At these values, the curve intersects x-axis. At 0, pi, 2 pi, it intersects x-axis. Correct. Now I will draw the graph now. So when I draw the graph here, you can see here, y-axis, x-axis origin I have taken. We substitute between 0 to 2 pi, they are asking. If we substitute 0, in the sine 0, 0, sine 0, 0, it will be 0 only. The graph will come like this. Between I can write pi by 2. Pi it intersects at pi. And it intersects pi and 3 pi by 2. And 2 pi. 2 pi. Now if I draw the graph, see this one. Sine 0, 0, put 0 is 0 only. At pi by 2. Pi by 2, this will be 0, you will get sine 2 into sine pi by 2, 1. You can check that value, it comes maximum value. You can consider whatever comes here, that is, I can write this is 1, this is 2, I can write. If you put 0, 0, if you put pi by 2, 2 into sine pi by 2. So you put here, when x is equal to pi by 2, check the y value. So 2 into sine pi by 2, 1, this will be 0. It comes y is equal to 2. Maximum it goes 2 here. At pi by 2, the graph will go like this. At pi, sine 180 is 0. Sine 2 pi, that is also you can see 0. Sine 180, everything will be 0. It will come like this, pi. Graph will come 3 pi by 2. At 2 pi also it intersects. The graph will come like this. This is the graph it comes. Same here. Here also limit 0 to pi, pi to 2 pi. 0 to pi, pi to 2 pi, the length is same. Down also you can see 3 pi by 2. If we take 3 pi by 2, you can check that. 2 into sine 3 pi by, you can see sine 2 into 3 pi by 2. You can check the value of this if you want. Maximum 2 pi it comes. You can verify this. 0 to 2 pi it comes, right? It intersects. To find area, the required area. To find this is the required area. I want to find this area. Inside I can find here. This is you can see this is the required area. I should find this area. Correct. Why? Because this goes to -2 here maximum and this goes to minimum -2 here. If we think this one, if we think about this one, sine 3 pi by 2, it comes -2. Roughly it comes -2 here. This is the point exactly, it will be -2 here. Same thing. Here also maximum 2, here also minimum -2. Why? Because you take 3 pi by 2, if we substitute 3 pi by 2, it will come -2. When x is equal to 3 pi by 2, so y will be -2. You will get like this. That means the area between 0 to 2 pi is equal to the area between pi to 2 pi. Both are same. The area both are same. You can find like previous problem, because 0 to pi, pi to 2 pi you can find, because this maximum height is 2, here the down also minimum -2. According that we can solve this problem easily. I can write required area equal to, the area is equal, I can write the area equal to 2 into 0 to pi. Because here height is 2, here also down is 2 only. 0 to pi, I can write 2 sin x, I can write the curve 2 sin x plus sin 2x dx. I can consider this. You take integral of this. If you take integral of that, now what can I do here? When I take integral of this, then I can write this one. See, 2 into integral sin x minus cos x, limit 0 to pi, plus sin 2x minus cos 2x by 2. Then I will take this place, I will write here. Nice to understand this. So the integral part I will write here. This part I will write here. This one to 2 into 2, you can write this is 2 into 2 sin x plus sin 2x. You will get minus 2 cos x, because 2 into minus 2 cos x. This one sin 2x means you will get minus 2 cos 2x by 2, limits 0 to pi. Again substitute the limits. Correct? You try to understand here. Integral sin x is minus cos x, minus 2 cos sin 2x minus cos 2x by 2. Here you won't get this 2, you won't get here. Like this. Because integral sin 2x minus cos 2x, derivative of 2x is 2, I should divide. Substitute the limits now. If we substitute the limits, correct, I can do that. If we substitute the limits here, I can find the value of this. So this will become 2 into minus upper limit cos 180 minus 1, it will be 2. Here cos 2 pi, how do you get minus 1 by 2? I can verify the upper limit I substituted here. When upper limit cos 2 into pi cos 180, so 2 into cos 2 pi, 0, you will get minus 1 by 2, minus, you substitute lower limit. If we substitute lower limit, see that if I substitute lower limit here, you can verify, I can substitute lower limit, 0, if I substitute 0, cos 0 is 1, you will get again minus 2, cos 0 is minus 2, again cos 0, minus 1 by 2. You can verify this. You will get 2 into, this will be 3 by 2, this is minus 5 plus 5 by 2, 5 by 2. Now you can see here, this is 2 into 3 by 2 plus 5 by 2, 8 by 2, 2 into 4. Answer is 8 square units. That is, answer is 8 square units. That is our answer. 8 square units. 8 square units. But remember here, what I am suggesting here, in this problem, if you are not able to understand this, here you can also take 0 to pi, pi to 2 pi also you can do that. Or I can do like this also. If the required area, I have taken required area is equal to 2 into. Why I have taken 2 into? This length 0 to pi, pi to 2 pi length is same. Here maximum 2, here maximum 2 here. The length of this, because the height is 2 units, the height is 2 units. That is the 2 into I have written. 8, your answer is 8 square units. 8 square units will get. Otherwise you split 0 to pi, pi to 2 pi you can split. You can split, you can do like previous problem. That was you can solve this. Now the next one I am going to explain now. So the next one, find the area of the larger part. Find the area of the larger part bounded by y equal to cos x and y equal to x plus 1 and y equal to 0. They mention all these three. See that one. What they are saying here? They are saying here now y equal to cos x, y equal to x plus 1 and y equal to 0. See that problem you can see now. I will refer that one now. Area of the larger part bounded by y equal to cos x, y equal to x plus 1 and y equal to 0. So now the important is draw the graph. Graph is important. Then after that we can complete. Easy to find the area. The graph is most important. I will explain the graph, how to draw the graph here. So y equal to cos x graph. So if I think this one, I will draw the graph of this one. So you can write this is a y x x dash origin. Between they are asking y equal to 0, cos x graph. The graph of cos x, it will cos 0 is 1, cos 180, cos pi by 2 0. The graph will come like this. Why? Because this one will be pi by 2 comma 0, cos 90 0. This point pi by 2 comma 0. This point minus pi by 2 comma 0. The graph of cos x, correct? But they given the line y equal to x plus 1. You think about the graph of this one. Here maximum what about this point will be 0 comma 1. So you think that point is 0 comma 1 on y axis. Why? Because cos 0 is 1, 0 comma 1. That point is 0 comma 1. When you are taking y equal to x plus 1 graph, y equal to x plus 1. So you take when y equal to 0, where it cuts x-axis, when y equal to 0, x equal to minus 1. When x equal to 0, y is equal to 1. So the graph will come like this. See the line, it comes like this. Because minus pi by 2, minus 3, minus pi by 2, minus 1.57, the graph will go like this. The graph will go like this. So this is the point I can consider. So that point will be observed. This point will be 0, you will get minus 1 comma 0. This point will be minus 1 comma 0. This point I will write here minus 1 comma 0, that point. So this point I actually passing through this. This is 0 comma 1 common point. This point is 0 comma 1. Same thing I have written this also 0 comma 1. Correct. They are asking area, because you try to think how to draw a graph of that. They are asking area of the larger part bounded by this. This is this is smaller part. They are asking larger part. So when they are asking larger part, so I can consider now only this is the area. This is the area required. This is the larger part in this. I can consider this area. Correct? This is the area, required area, larger part. So between minus 1 to 0 and 0 to pi by 2, both I should find. Now required area is equal to, I can write required area equal to, you can write required area is equal to, this I can write required area is equal to, but you can see between minus 1 to 0, between minus 1 to 0, one line is there. Along with, they told y equal to 0 means x-axis. Y equal to 0 meaning is x-axis. Upper curve, only line is there. So x plus 1, I can write x plus 1 dx plus 0 to pi by 2. 0 to pi by 2, curve is upper curve. Lower curve is x-axis. That is y equal to 0. So we will get only cos x dx. This will be cos x dx. Cos x dx. Now you can see x plus 1. If I this one, x square by 2 integration plus x, limits minus 1 to 0. This integral cos x sin x, limits 0 to pi by 2. Limit 0 to pi by 2. If I substitute this one value, you can see here 0, everything will be 0, applying minus 1. So 0 minus applying minus 1, you will get 1 by 2 minus 1. This is sin pi by 2. Apply limit sin pi by 2 1, sin 0 0. Correct. You can check the value here. The required answer is, this is 1 by 2, you will get 1 by 2 plus 1 on 3 by 2 square units. 3 by 2, your answer 3 by 2 square units. Three by 2 square units. Your answer 3 by 2 square units. Add this one 1 by 2 plus 1. 3 by 2 square unit. This is 3 by 2. 3 by 2 square units. That is your answer. 3 by 2 square units. Now coming to the next one. See the next one. Feel free to ask your doubts. If any doubt, please ask me. I am here to explain. Any number of times I will explain. Is it clear? You can ask any number of times. Is it clear? Then good. We'll do the next one now. Find the area bounded by the y equal to secant square x. Y equal to secant square x and mod x is equal to pi by 3. Y equal to secant square x, mod x is equal to pi by 3, y equal to 0 also. Y equal to 0 means x-axis, mod x equal to pi by 3. So when mod x equal to pi by 3 is given, you observe here, mod x is equal to pi by 3. Curve is given, y is equal to secant square x and y equal to 0 x-axis. The given mod x is equal to pi by 3 means x is equal to plus x equal to minus pi by 3 comma plus pi by 3. Between these two we should find plus pi by 3 minus pi by 3. Minus pi by 3. The graph is important. Try to understand the graph here. Then this will be easy to solve the problem. I will tell you the graph this one. You can think about when I am drawing the graph of this one. You can see here. I can draw the graph of this. Because minus pi by 3 pi by 3. Y-axis x dash y dash. So I can consider this is the origin. I can consider the saying here minus pi by 3 and plus pi by 3, correct, between. If we substitute 0, what about secant 0 is 1, the maximum value will be 1, the curve equation will be 1. But at minus pi by 3, you substitute minus pi by 3, we substitute secant of minus pi by 3. So we can secant of minus 60. It will be 2 square, 4, it goes to 4 here. The maximum will be 4 here. Somewhere if I mark here, this is 4. It will come here, maximum, the graph will come like this. This is 4. Up to here 4 it goes maximum 4. Why? Because at pi by 3, I can mention at pi by 3 exactly here, at pi by 3 here also pi by 3. Like this, the graph it will come like this. Right, it will go like this. Exactly at pi by 3 you can think. I can draw that line to understand. I can draw the line at pi by 3 this. At minus pi by 3. It touches at 4. So what is the required area here? This is the required area. In between. So this is the required area they are asking. Correct. In between. This green color and below red color, that is the required area. Curve is like this. Like this you can find. No, again this is symmetric. 0 to pi by 3 minus pi by 3 to 0. It is symmetric with respect to y-axis. Since it is symmetric with respect to y-axis, I can write required area equal to 2 into 0 to pi by 3. Because both are symmetric with respect. You can write this one, it is symmetric with respect to y-axis. Required area. You can write required area equal to. Easily I can write required area is equal to 2 into 0 to pi by 3 secant square x dx. Upper curve minus lower curve. Upper curve is secant square, lower curve is y equal to 0. Difference of these two. Difference of these two will be secant square x dx. But we know that integral secant square x is tan x. Integral secant square is tan x. I can write 2 into tan x limit 0 to pi by 3. Tan x. So 2 into tan pi by 3 minus tan 0. Upper limit by lower limit, just you substitute. Tan pi by 3. 2 into tan pi by 3, tan 60. It will be, you will get root 3. Tan 0, 0. Answer is 2 root 3 square units. 2 root 3 square unit. That will be your answer. 2 root 3 square units. 2 root 3 square units. Because I don't want this point. This is, if you want this point, if you write, you can write to understand. This is pi by 3 comma 4. This point is minus pi by 3 comma 4. Point of it if you want. If you want point of, I'm saying if you want point of intersection, we can write that. This is point minus pi by 3 comma 4, pi by 3 comma 4 here. This is pi by 3 comma 4. Pi by this point of intersection. If it is required, you can write. I want only between 0 to pi by 3. The point 2 root 3 square units. Now I will explain with the sixth one. Find the area bounded by the curve y equal to tan x the line x equal to pi by 4 and the x-axis. So they are given this and the x-axis. Now check, when they are given and the x-axis, area bound by curve y equal to tan x, line x equal to pi by 4 and the x-axis. See, in this, there is a simple one, y equal to line x equal to pi by 4. When they are finding this area, I can draw here. So this figure, this is a simple one only, not that much difficult. You can see here. Pi by 4. I can draw, this is pi by 4. So this is 0. We know that this is 0. Origin here. Tan pi by 4 is 1. Roughly I can put here 1. Tan 0, 0. Tan pi by, the curve goes like this. Correct? This is 1. Exactly 1, it coincides. Tan pi by 4 is equal to 1. Tan 0, 0. Tan pi by 4 is equal to 1. We get like this. Now, this is the required area. Correct? This is the required area between 0 to 1. The green color represents required area, right? This is 0 to pi. So answer I can write required area equal to integral 0 to pi by 4 tan x dx. Simple. 0 to pi by 4 tan x dx you can write. Integral tan x, we know that 2 log, we can write integral tan x log mod secant x. Integral tan x is log mod secant x. I can write this one, log mod secant x. Integral tan x dx log mod secant x. Limit 0 to pi by 4. Upper limit we substitute log secant pi by 4 minus log secant 0. So I can write log secant pi by 4. Secant pi by 4 is root 2. Log secant 0 is 1. Correct? We get secant 0. I can write log 1. Log 1 0. I can write this one log 2 power 1 by 2 minus 0. Logarithm property 1 by 2 log 2. Half log 2 square units. That's your answer. Half log 2 square units. Half log 2 square you can write. Half log 2 square units. This is square units. Half log 2 square units is your answer. Half log 2 square units. Right. I hope you understood this right. Tan x line x equal to pi by 4 and the x-axis. Is clear that? Yeah, understood that. Good, yeah, understood. Fine then. Then I will do the next one now. Draw a rough sketch of y equal to 2 cos x. Find the area for 0 less than or x less than 2 pi and x-axis. See in this problem. The 7th one. Draw a rough sketch. There's a draw a rough sketch. Y equal to 2 cos x between 0 to 2 pi and x-axis. That is important here. Now they are asking a rough sketch of this. You can see 2 cos x means between 0 to 2 pi. For example, if we take x equal to 0. If we take x equal to 0, y is equal to 2 cos 0. That will be 2. Maximum will be 2. 2 cos 0 will be 2. If we take it. If x equal to pi by 2. If we take x equal to pi by 2. Y is equal to 2 into cos pi by 2. 2 into cos pi by 2 will be 0. That will be 0. So to understand that I have written pi by 2 0. Similarly, if we take 3 pi by 2. If we take the values x equal to 3, x equal to pi also I can consider. If we take x equal to pi, it will be minus 2. Correct. When x equal to pi, the graph will become y is equal to 2 into cos 180. It will be minus 2. Then x is equal to 3 pi by 2. You take just get an idea I'm talking about all this. Or direct I can write curve also. When x equal to 3 pi by 2. So 2 into cos 3 pi by 2. That will be 0. And x equal to 2 pi. Final x equal to 2 pi. Including that x equal to 2 pi. If we take x is equal to 2 pi. Then y is equal to, it comes here exactly cos 2 pi. It will be cos 2 pi is 1. 2 into 1 2. Y is equal to 2. Now look into these values. I can draw the graph now. You can see now. What I will do now, I can draw the graph of this. Because we know that this is the origin. It approaches maximum value 2. Maximum value 2. So at pi by 2, 0 means the graph, you can think, the graph will come like this. It will go like this. Correct? It will go because this point we know the point is pi by 2. It's 0 pi by 2. Again at 3 pi by 2 also this one. This is 3 pi by 2. Correct? You can check this point also, I can write. This is 3 pi by 2. The graph is going on. Again at 2 pi, it will be 2 only. So what I will do now, when I extend the graph here, it will go up, right? It will go up like this. This x-axis I will extend this. Correct. When I have taken like this, the line, this is, you can consider this line, better the vertical line. But I should draw something because I should draw 2 here. Same, because 2 units. So this point I can consider, this point is 2 pi. It enters these points. Now what is the required area now? This is the required area. That is the required area, correct? So that is the shaded area is the required area. Correct? This is the required area. Now you can write required area is equal to 3 intervals 1, 2, 3. Because here I can consider 0 to pi by 2, 3 pi by 2, 2 pi length is same. Instead of taking this, I can write 2 into 0 to pi by 2 also. I can consider this is pi by 2 to 3 pi by 2. Pi by 2, 3 pi by 2. Now you can check that here. How to find area of this now? Required area. When I am talking, I can write required area equal to required 0 to pi by 2. 0 to pi by 2. The curve is 2 cos x. Right, 2 cos x dx plus pi by 2 to 3 pi by 2. Pi by 2 to 3 pi by 2 below. This is y. We know this is x-axis. We know that y, this is y equal to 0. Y equal to 0 minus 2 cos x. You will get minus 2 cos x dx. Minus 2 cos x dx. Correct. Again you will get this one. 3 pi by 2 to 2 pi. 3 pi by 2 to 2 pi. I can write this one. 3 pi by 2 to 2 pi. 3 pi to 2 pi. 3 pi by 2 to 2 pi. So 3 by 2 pi is this one. Curve is upper. So you will get 2 cos x dx. Always upper curve minus lower curve. 2 cos x minus y equal to 0. Here curve is below. So y equal to 0. This is y equal to 0 minus 2 cos x. Now we have to simplify now. Should be careful when you are simplifying this. I can write here. The integral part I will do now, which is equal to integral 2 cos x. It will be 2 sin x. Limits 0 to pi by 2. This is minus 2 sin x. Limits pi by 2, 3 pi by 2. This is 2 sin x. Limits 3 pi by 2 to 2 pi. Be careful. Many people, they may do mistake in the simplification. You should be careful now. When I am doing 2 into sin pi by 2, 1, sin 0, 0, minus 2 into sin 3 pi by 2 minus 1, sin pi by 2, 1. plus 2 into sine 2 pi 0, sine 3 pi by 2 minus 1. I can write like this. Now if we substitute the values here, you simplify total now. So which is equal to, I can write 2 plus this is 4 and this is 2. Total 8 square units. Your answer is 8 square units. That will be around 8 square units is your answer. 8 square units. I have 2 more problems. I hope you understood this. If any doubt you can ask me, I can explain again. Is it clear? I understood this. Is it clear? If I want to, I can repeat the problem. If I need doubt, I can repeat the problem. Clear? Then fine. 2 more problems. It takes around 10 minutes. I can complete the session. See, draw a rough sketch of y equal to sine 2x. Find the area enclosed by the curve x-axis and the line x equal to pi by 4 and x equal to 3 pi by 4. Pi by x equal to 3 pi by 4. They are asking this one. But then y equal to sketch of y equal to sine 2x between pi by 4 and 3 pi by 4. They are asking pi by 4 and 3 pi by 4. They are asking pi by 4 and 3 pi by 4. So you know the graph of sine 2x, you should draw the graph this one. But the given here, x value between pi by 4 to 3 by 4, you remember here, given pi by 4 less than x is equal less than or equal x less than or equal to 3 pi by 4. The given. If I divide this by 2, pi by 2 less than or equal to 2x less than or equal to 3 pi by 2. Between pi by 2, 3 pi by 2 it comes. Correct? And 2x. I am talking about 2x. If we take sine 2x, maximum will be, if we take this one, the maximum value you can see the graph. When I am taking the graph, if we take sine, this is sine pi by 2, 1 less than or equal to sine 2x less than sine 3 pi by 2, it will come minus 1. Maximum between 1 and minus 1 it comes 3 pi by 2, right? But the x value is between only. The graph will come between 1 and minus. You can see here, I can write. So I didn't wrong here, reverse when I am using sine values. Pi by 2 to 3 pi by 2. The values are written when I am dividing this one, we got pi by 2, 3 pi by 2. Sine 90 comes 1. The graph at 90. Sine 2x. When I have taken the values pi by 4 less than 2x less than 3 pi by 2. Now I will draw the graph. Then we will see the discussion. I will explain the graph. Y equal to sine 2x. But x value is between pi by 4 to 3 by 4 I should consider. Between pi by 4 to 3 by 4 I should consider. When I am drawing the graph. Sine graph. But this is a graph of sine 2x. Maximum will be 1 only. Sine 91. Correct. That's the remember here. When I am taking here. 2x lies between these two values. When I have taken the graph, maximum it comes 1. So the graph will go like this. Sine 0, 0. It will go like this at pi by 4, 1. And if we substitute pi by 2, it's like that 2 into pi by 2. 2 into pi by 2 sine pi 0 it will come. So it will come at pi by 2, that will be 0. It touches like this. Correct. The graph will go like this. So this will be, I can write here. This is the reason when I have taken exactly, this is the reason I can take this is pi by 4. At pi by 4, because substitute pi by 4, it comes 1. This value is pi, this is pi. It is pi. Sine 180 is 0, it comes. Sine will get sine 0. Sine you can substitute here. X is equal to, if I search not pi by 2. Pi by 4, be careful here. This is pi by 4. This is pi by 2, and this will be 3 pi by 4. When I have taken 3 pi by, this is point is, you can write, substituting the value here. Now I can get the value, and then this I am considering this value. Be careful here. This one it comes. The reason when I am taking the entire value, pi by 2, and I substitute sine into 2 into pi by 2, it will come sine, correct. Sine pi, it cuts here, 0, correct. When I have taken the value of 3 pi by 4, you can check here, where it comes 3 pi by 4. Pi by 2, this will be 3 pi by 4. This is 3 pi by 4. This will be sine, you can see here, 0 again. If I take it, that is pi. If I take this is pi, I don't want up to here. They are asking pi by 4 to 3 pi by 4. So I can join like this. All up to here is required. So the required area is this one. Be careful here. The shaded area is the required area. Because this is pi by 4 to 3 pi by 4. X values follow this only, right? Pi by 4 to 3 pi by 4. Only that one you should check. Pi by, this is required area. This is up to 3, this is 3 pi by 4. Correct? This point is 3 pi by 4, this point, what I have written here. Correct? That is 3 pi by 4. This is required area, shared area is required area, correct. Just understand this required area, pi by 4 to 3 pi by 4. Now we can write the required area is equal to, I can express now required area equal to, between 0, pi by 4 to pi by 2, I can write pi by 4 to pi by 2, pi by 4 to pi by 2. This is an upper curve, that will be sine 2x dx, sine 2x dx, plus pi by 2, 3 pi by 4. These are the x values, pi by 2, 3 pi by 4. This is y, because we know this is x-axis, y equal to 0, below, y equal to 0, upper curve minus lower curve, minus sine 2x dx, minus sine 2x dx. Now you can find the value now. Now simplify, integral sine 2x minus cos 2x by 2, minus cos 2x by 2, minus cos 2x by 2. Limits pi by 4 to pi by 2, minus this one again, integral sine 2x minus plus, it becomes plus cos 2x, because you will get this is minus, you will get minus here, integral sine 2x minus cos 2x by 2, limits pi by 2 to 3 pi by 4. Now you can substitute the values now. You substitute the values here. Here the area should come, this is off, one only should come. This is because here little the rough sketch I have done. Because this is rough sketch only. If we substitute the values now, if I substitute the values here, this will come upper limit. This is 2 into pi by 2 cos pi. It will come. See, substitute the values here. The final value it come here. 2 into pi upper limit, pi by 2, right? 2 into pi by 2 cos will get, correct. So 2 into pi by minus it comes here. Substitute the value, verify here. This minus of upper limit pi by 2 into pi by 2 cos 180 minus 1 minus of minus 1 by 2, correct, minus 1 by 2 minus lower limit cos 2 into pi by 4, it will be 0, it comes, minus minus plus, it will be cos 3, 2 into 3 pi by 4, 3 pi by 2, 0 it will come, and cos pi by 2 cos pi, it will come 0, and this is also it come 1 by 2. You can check that. Minus 1, it will be plus 1 by 2. So plus 1 by 2 plus 1 by 2, it comes 1 square unit. 1 square unit. That's your answer, 1 square unit. That is the required area. You got 1 square unit. 1 square unit. So these are only rough sketch. Because area should be same compared to the rough sketch, this one. Now I'm going to complete the last problem now. I'm going to complete the last problem. With this I can complete the session. The last problem. Now look at the last problem now. Find the area between the curve y equal x by pi plus 2 sine square x, x-axis, and the ordinates x equal to 0 and x equal to pi. If you draw the graph, because graph or if you draw the graph, that will be easy. Not that much difficult here. Between the ordinates x equal to 0 and x equal to pi. They are saying ordinates x equal to 0 and x equal to pi. X equal to 0 and x equal to pi. Because x equal to, this is x-axis, y-axis, origin I have taken this one. Suppose the given x is, this is x equal to 0. Between x equal to pi. That is when x equal to 0. So check that when x equal to 0. What y value here? When x equal to 0. Check the graph y equal to 0. X equal to 0. This will be 0 only, right? The graph goes like this. Maximum the graph will I can write here. This is 1, 2. It goes 3. One to the points given 1, 2, 3. Zero to pi. I can consider the values here. This is 0. I can write pi by 4, pi by 2, and pi I can write. Some values I can write to understand this. If we substitute 0, the graph will come. You can see the graph passing through 0, 0. Substitute here. 0, everything 0 will come. If we substitute pi by 4, the graph will go maximum pi by 4, 2 into sine pi by 4, 1 by root 2, sine 45, 1 by root 2, whole square, 1 by 2, 1. To get 1 plus, you will get pi by 4 means you will get, you can cancel this one, pi 1 by 4, you will get 1 point something, the graph will go up, right? If we substitute this pi by 4, check that, and pi by 4 if we substitute, x means pi by 4, pi will get 1 by 4 plus, you will get 2 into 1 by 2, correct? More than 1 it comes, it will go like this. The graph will go like this, it will come, it will go up. Because when I am taking the value, the graph will go up like this for 2 point something, it will come down. Between pi to pi, if I come here, if I take exactly pi, if I take exactly at pi, you can check at pi by 2 if we take, check that value if I take at pi by 2. What are the values of pi by 2? X equal to pi by 2 if we take, y is equal to pi by 2. Pi by 2 means this will be 1, 2 plus pi by 2, 2 and a half, more than 2 it comes like this. And that is the reason I have written like here. At pi by 2 it goes maximum 2 point something it will go. Between pi by 2 to pi if we take it, if we come, the value will come down between pi by 2 to pi. Because when from sine 90 is 1, sine 180 is 0, the value is going down here, is coming down. At 180 it will be 0, right? If we take it, the value it will come. Suppose here, substitute x is equal to pi. X is equal to pi, you can, at pi by 2, I have written 2 point something, x is equal to pi by 2. This is 2 plus pi by 2, 2 and a half. Pi, let x is equal to pi by 2, it will come 1 by 2, 2 and a half this one. Roughly it come between 2 and 3. X is equal to pi. If you take x is equal to pi, y equal to pi will cancel. You will get 1 plus 0, you will get 1 only. It will come down. At pi the value it will come down. So you can think, if I draw the graph, the line x is equal to pi, the graph will come down like this. Correct? It's coming down, again it's going up like this. Graph will go like this. The graph will go and will go up. like this. Again, I can move up the graph, right? So this I can write, this is the line, this is the pi. It will come like this. This is a rough diagram only. It will go up like this. X is equal to pi. It comes almost equal to like this. If I take plus at pi, if it's pi, that value is 1 only. Correct. Roughly it comes like this. Value 1. So this is the required area. I can share this one. This is the inside the, this is the required area. Correct. This is the required area. To understand this, I will written like this, right? The shaded part, completely this is the required area. This is the required area between 0 to pi. Now you can write required area equal between 0 to pi. Required area equal to required area equal, I can write between 0 to pi. Between 0 to pi, only curve this one. Again, this is upper curve, lower curve is x-axis. This is y equal to 0. You can write x by pi plus 2 sine square x dx. 2 sine square x dx. Correct? This one I should do that. 2 sine square x dx. No, I can write here 0 to pi 2 sine square x dx. But this one, for our convenience, you can write 2 sine square x means 1 plus cos 2x. 0 to pi x by pi. What is 2 sine square x? 1 plus cos 2x. Correct? 1 plus cos 2x. Now I can integrate now. This will be x by x square by 2 pi. X square by 2 pi. X square by 2 pi plus 1 means x. Cos 2x means sin 2x by 2. Sin 2x by 2, limits 0 to pi. Limit 0 to pi. Now substitute the values. If we substitute the values, upper limit pi square, we will get pi square, pi will get cancelled here. Correct, pi by 2 it comes, pi by 2 plus pi, sin 2 into pi, sin 2 pi, sin 2 pi, sin 0, 0. Lower limit if we substitute everything 0. Correct, it will come pi by 2 plus pi, 3 pi by 2 square units. 3 pi by 2 square units. 3 pi by 2 square units. That is the required answer. So I covered everything in this problem. Try to understand the problem. The graphs is important. Try to understand the graph. Then required area. It is 0 to pi. So you will get, this is the required area. Answer is, you will get required area is equal to this. Substitute in this 3 pi by 2 square units. So with this I have completed all 9 problems. Today's session completed. Tomorrow's session I am going to explain only like ellipse, circle and triangle related problems. With this I can complete the session tomorrow. It will be complete tomorrow. The complete session it will be completed. Application of integrals I can complete tomorrow. Fine, hope understood. Any specific problem should I explain? Please let me know, I can explain again. Do you want any specific problem to explain? I can explain if you want any specific problem. Is required to explain any specific problem? I can explain. Then fine. It's good. See you then. Good night. Then fine.